So I'd like to connect back to what we've been doing in 2.8 so far. In 2.8, remember we used like a number line type thing and some test values to test where, in what intervals, or what intervals would be, in this case, example 3 less than or equal to 0. In example 2, where we are going to be greater than 0. So take a second and look back at your notes. We've done some good work. In 2.7, we graphed rational functions, and we thought about asymptotes, we thought about x-intercepts and y-intercepts, and we also thought about where holes might happen. Now, in example 5, we need to figure out in what interval this rational expression would be less than or equal to 0. Notice that it's not a function technically because we don't have that input x output y relationship. There's no y, so it's not really a function. Excuse me. So what we do know for sure, connecting back to what we learned before, we know that x cannot equal -3. X cannot equal -3 because you'd have division by 0. So what this means then is that x equals -3 is a vertical asymptote. Something else we know is that any unique zeros of the numerator are x-intercepts. That's an x-intercept. Because it's an x-intercept, it's a 0 on our number line. All right, so when I go to think about, I'm going to say x equals 2 up here. When I think about my test strip here, remember that -3 is going to be an asymptote, and then 2 is going to be a 0. So what I have going on here are 3 intervals that I need to test. I need to test from -infinity to -3. I'm going to use a parenthesis there because it's an asymptote and I can never equal -3. Our second interval is from -3 to 2. Again, a parenthesis at -3 because it's an asymptote, a hard bracket at 2 because 2 is a 0. And then finally from 2 to infinity. Now, I'm using that hard bracket because I'm looking for the values where x is less than or equal to 0. Time for some test values. I'm going to test -10. I'm going to test 0, and I'm going to test +10. And I just chose those numbers because they're easy for me to work with, and they fall in these intervals. So if I plug in -10, I have -12 over +7, absolute value of -7. And so that outcome is going to be negative. If I plug in 0, I have -2 over +3, which again is 0. If I plug in +10, I have 8 over 13, which is positive. So remember, the question is asking, where is the rational expression x minus 2 over the absolute value of x plus 3? Where is it less than or equal to 0? So to answer the question, I would say from -infinity to -3 and from -3 to 2. All right, now you are not allowed to use your calculator, but just to prove to you that that's a truly legit answer, let's take a sneak peek or a quick peek at the graph. So I typed it in. When I look at the graph, look at where am I below the x-axis? So where am I negative? From here and then all of this in here. So from -infinity to -3, step over that asymptote, and then from -3 to +2. So, all right, I can prove it to you graphically. But like I said, I want you to do this by hand. No calculator allowed. In example 6, I have 2 rational expressions. What I need to do is write this as one big rational expression. So I'm going to think of 5 times x plus 1 plus 3 times x plus 3. I'm multiplying like so to get a common denominator of x plus 3 times x minus 1. Now in the numerator, I'm going to distribute and I'm going to combine like terms. This becomes 8x plus 4 over x plus 3 and x minus 1. I'm looking for where the values of x are going to be greater than 0. So what do I know for sure? I know that I'm going to have some vertical asymptotes at x equals -3 and x equals +1. I know that I'm going to have some zeros, or a 0, at let's see, x would be -4 divided by 8 or -1/2. So I'm going to have a 0 at -1/2, comma 0. This is just kind of my thought process here. I was just thinking. All right, we're ready to make like our test strip here, our little number line jobby. So -3 and 1 are going to be asymptotes. -1/2, I'm going to put that right about here, and that's a 0. Okay, so test value time. I'm testing 3 intervals. Actually, I'm testing 4 intervals. What are my 4 intervals? From -∞ to -3. I'm testing from -3 to -1/2. I'm testing -1/2 to 1, and then I'm testing from 1 to infinity. 4 intervals. Test values now. So for my test values, I'm going to go -10, -2, 0, and +10. These are my test values. All right, well, from here, I'm going back, I'm kind of looking at the original function. So 5 over -7 plus 3 over -11, this is definitely going to be negative. If I plugged in -2, and again, I'm testing this guy just because it's a little bit easier for me to read, maybe, I don't know. You can test this, or you could even test this, whatever you want. If I plugged in -2 though, I have 5 over 1 plus 3 over -3. That's going to be -1 plus 5. This is going to be positive. If I plug in 0, I've got 5/3 plus 3 over -1. Well, 5/3 is 1.6 repeating. -3, that's going to be something negative. And then if I plug in 10, 5 over 13 plus 3 over 9, that's going to be something positive. All right, the question is, where is the function greater than 0? Or not the function, where is the expression greater than 0? So the expression is greater than 0 from -3 to -1/2, and also from 1 to infinity. Before I walk away from this problem, should I have used brackets at all? Nah, I don't want to use brackets because of the nature of the symbol. Because of the nature of that symbol. And then remember, these are asymptotes, so they're off limits. These asymptotes are off limits. Okay, and if you wanted to check your answer, you could type it into the graphing calculator, but I'm not going to. You're welcome to, though. All right, finish that up. Would it be helpful to you to rewatch this video?